Okay, first job today, let's review iterator pattern. After you struggle a little bit through lab number 2, hopefully you got some question to ask me about iterator pattern. Hopefully the review is going to answer some of them. If you got further question, let me know. Okay, I would like to review the iterator pattern very quickly. And remember the way we talk about iterator pattern. So far, you are mainly the clients of the iterator pattern. If you got any iterator pattern supported, you can definitely use the across syntax, like how you can across the linked list, array, or even hash table, any collection library that's iterable. But lab number 2 is really about how you can be the supplier of the iterator pattern. So that's a focus for last time's lecture. Let me just review very quickly how you can do it from the supplier side. Okay, so there are 2 cases over here. Let's review this diagram here, but using a slightly different way to illustrate it. So here we are in the supplier, and by the way, in bond diagram, the way you draw packages or cluster, that's how we call in Eiffel, or packages in Java term, is to draw the dotted line to surround the relevant classes. That's how you group classes into different cluster, like a model or test or root. Okay, let's talk about case number 1. Let's say I have a simple class, for example, if you see from the slides from last week, so the one we had last time was like this. Let me just show you the first case. Let's say we have a very simple card class where the orders, the only implementation attribute is of type array, okay? An array is already a collection class, which is also iterable, which means by definition, it should already support the new cursor feature. Let's see how this will make sense from the diagram, okay? First of all, case number 1. I'll use the blue over here for case number 1, okay? Case 1, the easy case. So now the card class, basically, first of all, it is iterable. So I will put card over here. At the same time, there is also a client-supplier relation, as we can see from the code, which is the orders happens to be a supplier for the card class, right? We are making use of, the array happens to be a supplier for the card class since we're using it, okay? So what I will do is, I will draw another client-supplier relation over here, okay, like this. Okay, you can see it's double arrow, and this is a single line arrow. So this line over here is inheritance. This double arrow line here is client-supplier. Don't get confused. Okay, any questions so far based on these 2 relations? Okay, so now let's talk further. Given these 2 relations over here, and specifically let's talk about this one here. If you inherit from iterable, you are obliged to implement this defer or abstract feature called new cursor. So now for the card class, we have to implement the new cursor feature for sure. We are, that's our obligation to be the descendants of the iterable class. But now, how do we implement the new cursor? In this case, it's very easy because remember the array class over here is our supplier. And the array class, guess what, is also a descendant of the iterable class. So that means it must have already implemented the new cursor feature. So that means we can simply reuse it. So the way we implement the new cursor over here is by simply saying, oh, by the way, for client supplier, you should always specify which feature the name. So in this case, it's orders. So I will put orders over here. Okay, it's an array of orders. And then over here, the new cursor can simply be, let me be a little bit informal here. You can simply say new cursor is going to return orders dot new cursor over here. Okay, you can see the new cursor over here is already defined in the array class. Okay, it's guaranteed. That's case number 1, the easy case. Any question about the first case? Yes. Orders, you mean the decoration? Yes. If you look at the Eiffel code, you can see that's the only attributes for implementation, which is an array of order. That is why we have a client-supplier relation over here. Inherits from iterable because we want the card to be iterable.
Right, but you're saying that since you're implementing something with type array, which already has a type iterable, you can use that.
Correct. Let me say the logic again. It goes like this. First of all, we have this inheritance relation over here. Because card inherits from iterable, So we have to implement new cursor feature. But how do we implement that? The easy case is, since we already got a supplier array who is also a descendant of iterable, and for all the collection classes, it's guaranteed the new cursor is already implemented, so we can simply reuse it. That's case number one. One thing to note, there's a slight notation you should notice. Whenever you see star over here, that simply means deferred or abstract, unimplemented. And whenever you see plus over here, Eiffel term, it simply means effective or implemented, non-deferred. Okay? So here you can see for the new cursor feature over here, for every collection class is already implemented, so you can just reuse it for free. Question? So that one, the indexable iteration cursor is simply just one example where all the collection class, they simply just implement that. Okay, it's something that that's already implemented. Don't have to worry about them. Okay. Okay. Any question about our first case? Yes. Which one? The plus. Okay. The plus simply plus is as opposed to, you can see first of all, the iterable class has star over here, right? That means abstract. In basically like Java, if there's at least one method in your class that is abstract, the class is abstract, right? So now the new cursor in the iterable level is simply deferred, which means any descendants, you have to try to implement that, right? For the collection cluster, iterable collection over here, so you can see array, linked list, and array list, because they are not deferred, which means every feature has been implemented, including the new cursor. That is why here we put plus. That's the reason. Okay, case number one. Now, for case number two, just slight more complication here. The only slight more complication is we cannot really get any collection new cursor for free. We have to implement the cursor ourselves. So what does it mean? So let me use a slightly different color here to illustrate. What about I just use pink? So pink would be case number two. Let's see how the logic would go. And the example I gave to you over here is something called generic book. Let me call it book. In the case of the book, we actually got two implementation attributes. Similar to your lab number two, you got three, right? The idea is for individual arrays over here, they do support a new cursor, but you cannot simply just compose two new cursor into a new one, right? You have to implement by yourself, right? So now if you go back to the diagram over here, how does it work? So what I will do is I will put a new inheritance over here. So there's an inheritance arrow over here. And then I'll just call it book. Okay, book. And then the book actually got two client-supplier relationship, right? So it will basically got something similar over here, also like a double line arrow over here. But now in this case, rather than just a single attribute, we got two attributes. We got names, and also we got records. But the problem is the names does support new cursor. The records also support another new cursor, but it's really difficult to combine two new cursors together. Of course, you can write a helper feature to do that, but it's up to you. Okay? So the idea is you have to do some extra work. So the extra work is going to be in the book level over here, we have to implement some new cursor. Okay? How do we implement that? What we have to do is we have to create a new descendant class of the iteration cursor. For example, let me call that maybe my cursor. I'll give you more detail about how my cursor should look like. Let's say my cursor. Okay? Again, you can see the iteration cursor itself is deferred, which means for any descendants, you have to implement the after, item, and fourth. Okay? That's what you have to do. Basically like a tuple iteration cursor or record iteration cursor for your case. So once I have got the my cursor over here, what I want to do is I have a client-supplier relationship over here. Okay, this is a client-supplier. And this would simply be new cursor. Okay, like that. Of course, in my cursor over here, let me be more precise, you have to implement after, so that it's effective, is a plus. And also you have to implement item, which will become a plus. Also, you have to implement fourth, also will be a plus, effective. Okay, that's case number two. You can see the extra bits you have to do is that for the new cursor part over here, you have to do some extra work. Define the my cursor over here, and make sure it inherits from the iteration cursor, and also you gotta implement all these features after item and fourth. That's second case. Questions? Yes, Raymond first. My cursor is a class, yes. Oh, there are two ways you can draw classes, okay? Since you mentioned. So one way is the more detailed way. For example, you can see iterable over here. We simply list the relevant feature, like a rectangle box. Another way to draw the classes, for example, like for the case of the cart, I simply just draw oval shape. Just give the name of the class. There are two ways to do it. Okay, any question about the second case? Yes. Okay, the entire logic again, sure. Okay, let me just undo these colors over here. They can be a little bit invisible, okay? Let's do it again. Step number one, we need a book class. We wanted to make it iterable, right? We say book should inherit from iterable, okay? That will oblige us to actually implement a new cursor feature, right? Given that the book has two suppliers of type array, the names and the records, because you can see from the Eiffel code, we got names and records over here of type array. So we got client supplier. But the problem is, this is really why case one is different from case two. In case number two, it's difficult to directly compose two new cursors call into one. Because you can see for names over here, you can call names.new cursor. That's a one return value, right? And you can also call records.new cursor. That's another return value. But they don't really just combine them together automatically. Yes, exactly. So the way you want the iteration cursor for book to work is not just to give two iteration cursors. You want to somehow give a single one, and every time it's going to return, I will show you some illustration, but the intuition is when you are given more than one new cursor return values, you have to write some logic by yourself to combine them together. Okay? So now, given that we agree on this, so that's why we have to create over here. We have to create a new class called myCursor. Can be any name. And myCursor has to inherit from the iteration cursor. That's a typing constraint. Okay? So once you inherit from the iteration cursor, you have to implement all the defer feature after item and fourth with star, right? They are abstract at the interface level. But now in the myCursor, I have to make sure all of them are implemented with a plus. That's how I show you the architecture. Okay, after this, one more arrow to show you. And the book, now if I say new cursor, is going to return my cursor, right? That's why I also got this client supplier here. Questions?
Professor, this is the new cursor for array plus the iterable collection. Cursor arrow that's coming out of that.
Okay, so that simply means you can see that over here. The question was, let's say array class is over here, right? You can see every class in the iterable collection, every class there in the cluster, array, linked list, and array list. You can see there's an arrow I draw over here. So that means all of them, each one of them inherits from the iterable, which means each one of them has to implement a new cursor feature. So which means it's already done for you as part of the library. So you can use them whenever necessary for free. Oh, that's exactly what I meant. So you can see that over here, for example, array already got a new cursor feature supported, and that's this new cursor over here, right? And the new cursor is of type just indexable iteration cursor, or just a name for the library class. Yes? No, it's different classes. So my cursor over here is a class that we create by ourselves. The indexable iteration cursor is already there in the part of the library. No, as you see the arrow over here, my cursor inherits from the iteration cursor. What? The indexable iteration cursor is already there because for array, linked list, and array list to support a new cursor feature, you just create this separate class over here, right? And then to support the new cursor for the book, you just create a separate class to do the job. So every time if you have a new application, you just need a new class to actually customize your need. That's why you need different classes. But the common ancestor for these classes are iteration cursor. Make sense? Yeah. Okay, any question? Yes.
So when I initialize the array for names and then I initialize the array for records, do they get two cursors? Like, do they each get a cursor?
Correct. You wouldn't say they already got a cursor. You only get a cursor when you call the new feature, right? So the question was, let's say for the book class over here, right? We got two attributes over here, names and records, right? Each one of them, you can call the new cursor on them. For example, you can say something like this. Let's say here, we got names and records. I'll put it here. You can say names dot new cursor. You can also say records dot new cursor. But each one of them is a different cursor objects. So they are two independent objects. But what you need is a single one that is going to combine the two together. It cannot be done automatically. It has to be done by you as a programmer. All right? Yes.
Basically, the my cursor after item import, it's basically just taking the name's new cursor.
Correct, correct. I will show you one more diagram in just a bit, in the next slide. But it's a very good observation. Basically, my cursor over here is very, very specific to what the book is going to be implemented, because to create my cursor, you have to pass names and records as information. Okay? Yeah, we'll get there. Questions? Yes.
Just to clarify, so basically here in case 2, we're actually creating two separate cursors for the name and for the record.
We don't really create separate cursors for names and records. We just create a new class called myCursor. So somehow myCursor is going to take information from the names and from the records. And maybe how about this? After I show the next diagram at the runtime, hopefully you'll be a little bit clearer. Okay, yeah. But save your question. Maybe it will be answered. If not, you can ask me again.
So for the my cursor, instead of inheriting from the iterator cursor, can you also inherit from the indexable string?
Okay, the question was, for the my cursor over here, instead of inheriting from iteration cursor, can I inherit my cursor maybe from the indexable iteration cursor? Okay, my answer to that would be maybe yes. You gotta try, because if you do that, let's say if I put my cursor over here, the consequence is the compiler will still work, because my cursor indirectly is still a descendant of iteration cursor. So as far as the compiler is concerned, as long as the return type is of type iteration cursor, you're safe. But you gotta make sure the logic actually works. It's possible. You can try, definitely. Okay. Okay, any other question before I show some runtime diagram? Yeah.
So does the new cursor, which hold, like, what type would the item be for?
Yes, we'll get there. The question was, what would the item look like when we call it on the new cursor? We'll get there. Remember, for each new cursor you get support for after, item, and forth. But let's have a look to see how things work. Okay. Before I show you some runtime diagram, I'd like to just remind you over here. First of all, you can see new cursor over here. It returns any type that can be a subclass of iteration cursor. Okay. And I'll talk about the tuple in just a moment. And then the actual type is my iteration cursor, which is exactly the class we just created, right? The descendant class of my iteration cursor, basically, my cursor over here. Okay? And then how do we implement that? Notice one thing. The way we create a cursor objects, we have to give all the details so that the cursor can actually create, can be initialized. We have to give all the necessary information, in this case, the names and the records, right? And then in the next slides over here, I just show you some more detail over here, like how you can implement the item, how you can implement after, how you can implement forth. Okay? I'll let you go over the details for this code over here. What I want to show you really is to see how everything works together at the runtime. That's more important. Why are we doing this? Let me give you one more slide before I show you the runtime diagram. Okay? I would like to just emphasize the information hiding principle again. Okay? This is really one of the most important principles we're going to cover multiple times for this course. So information hiding, basically you want to hide certain information from the clients. But what do you want to hide? So here is a design decision you have to make, maybe for the projects. So in the project report, you have to tell me how you satisfy the information hiding principle. For example, in this case, the general principle is if there's any design decision for your implementation that is possible to change in the future, you should hide them as private from the clients so that if they really happen to change, it wouldn't affect the API of your class, so it wouldn't affect any of the client's code, as we showed last time. If you change from array into linked list, you want to make sure the client should be unaffected. Otherwise they'll be quite upset. Okay? That's the information hiding principle. Let's see how the iterator pattern is going to work at a runtime. Let's go over it together. Okay? Let me just make it a little bit smaller. Okay? Don't panic. Let's go piece by piece. Okay? First of all, let's focus on the first class over here. Sorry, this should be called book. I'll change the typo when I update the slide. This should be book. Okay? The book that we just talked about. Let's say we got a book class. Let me just use different color. That may be a little bit better to do the fix. So this guy here should be book. Okay? And the book, since we want to make it iterable, so that is why we say inherits from iterable. Okay? I will talk about a tuple over there in just a moment. Okay? Because there's also some decision you have to make as a supplier for the iterable. Okay? So now, the way, this is my convention for the coloring. Okay? Whenever you see the dark colors over here, those are the private attributes, which means any client outside from the book class, they cannot get access to them. For example, the names and the records, they are simply private, which means only the book class can get access to them. On the other hand, the new cursor feature over here is public, which means any clients who wants to use this iterable book class, the only thing they can access will be the new cursor. That's the only way. Okay, that's a naming, that's a coloring convention. Okay, let's explain more about the book class. I want to show you over here. Let's say the internal structure for the book will be, we have two arrays over here. We have one array for the names, and we have the other array for the records, right? And the underlying data structure. And then the names has a reference to it, and the records has a reference to it. Okay? And the gray box over here that I created over here simply tells you that this box is completely black box for the clients. The client can never see what's really under the hood, okay, under the box, because this is kind of the information hiding principle. The client don't have to worry about how exactly we implement the book. At the moment, we simply use two linear structure to implement the book. We might change that to a single binary search tree later, or we might later change that to maybe a hash table, etc. Right? But since that, the names and records are completely private, so that's not a concern for the clients. Okay, so far so good. The next question is, for any clients who wants to use the book class, how can they get access to the underlying items, right? So the principle is, we don't want them to just get the access to the two arrays directly. We want to give them some abstraction objects, which is iterator, in which case they will simply get the item one at a time. They wouldn't get access to the entire two arrays at one go. Okay? Let's illustrate how this is going to happen. Okay. So now let's think about, let's say we have the book object over here. Let's say the book, we simply say B, okay? B. When the client say b.new cursor, because the cursor over here is public, so that's the only feature the client can call. When they call new cursor, what's going to happen is at the runtime, there's going to be a new object of type iteration cursor, right? Remember what we had before, iteration cursor. I'll just put iteration cursor over here. Okay, that's the type over here. And then for the iteration cursor object over here, somehow the iteration cursor has to initialize its internal states also for maybe the values 1, values 2, and also maybe some cursor position. Let's say initial cursor position is simply 1. Okay, what does that mean? Okay, let me give you one illustration here. What we want to know from the client's point of view, because we know the way it works currently, we want to associate each name with its corresponding value at the same position, right? So let's say, for example, the first item to be returned to the clients by the cursor should be the combination of names 1 and records 1. That should be the very first item. Okay? So now let me show you this. So for the first time, let's say cursor C, okay, is assigned to b.new cursor. When I say the first time c.item, so what do I expect to return over here? I expect to return just a single value, but that single value must consist of basically a name and a record, right? A name and record are two different values, but how can we combine them into one? Okay, there are two ways you can do. For example, for lab number 2, either you can use the default, the predefined class in Eiffel called tuple, like a pair. I can say it's simply a tuple of name and record. That's one way. Or I can say each item is simply maybe a record class, and the record class has two attributes, a name and record. That will also work. Okay, you got at least two possible ways to do it. Let me just show you here. Okay, so whenever you say c.item over here, because the cursor position is at 1 at the moment, so that means the iteration cursor that we are using right now is going to grab name at position 1 and records at position 1, and then it's going to create some objects at the runtime. Let's say it's going to create some record objects. What it will do is it's going to create some record objects over here, let's say record. And the record object is going to get maybe name and value, okay? And the name is going to point to maybe the name, I didn't really draw the object here, but let's say some name object over here, the name, and also it's going to point to some value object as well. Okay, name and value. Okay, that's a record, which contains this name and this value. Okay, and this is what the clients will get, just the record. The client wouldn't really get exactly these two arrays directly. They will only get just a record object over here. And the record object is created by the iteration cursor. Okay, after we call this, one more thing. What about when the clients say, maybe after this, c.fourth? One way to do it can be, you just increment the counter over here from 1 to 2. Okay, after that, if I call c.item again, so what does that mean? That means this time we want to combine different positions value, right? I want to combine this position 2, get a name, position 2 also get a record, and then out of them, I will create just another record object over here. Another record objects, which has also name and value. And then c.item over here is going to point there. Okay, any question before I move on? Yes, question. Yeah. Yeah. Tuple, yeah. Yeah.
Another one is return it as a record.
Yes.
Which contains both the name.
Correct. So you can see that information we are really talking about basically name and record, right? So these are the two information extracted from the two arrays. But how you present that information to the clients is completely up to the cursor. You can present the two things as a tuple, or you can present the two things as a record objects. Doesn't matter. It doesn't really matter, just the form. So it depends on what the clients need. So in lab number 2, I just give you two options there. When you call maybe the new cursor feature for your database, in that case, each item is going to be a tuple. In the case where it's another cursor, what each item the client will get will be just a record. So it's really just give you different options.
Do we have to implement both options?
Of course, you got to implement both options, right? All right, questions?
The new record object
Yeah.
implemented in our iteration in our new cursor class.
Your iteration cursor class, yes.
Like
Correct.
under item.
Under item, correct. Okay, let me just emphasize. It's very good. Let me re-emphasize again. So this is exactly the point you want to follow. Okay, let's say this. Remember, so far I created one record object over here when the cursor position was 1. I created a second record object when the cursor position was at 2, right? So who actually created these two record objects? Iteration cursor. Remember, iteration cursor got access to the underlying data structure, and these access are not really seen by the clients. So what the iteration cursor can do, they can simply, since my cursor position, let's say at the moment is simply just at 1, I'm going to grab these two data, and then I'm going to create something that can be accessed by the clients. For example, a tuple, or just a record objects, right?
Do we have to inherit something from how can the iteration cursor see the array?
Okay, how can the iteration cursor see the array? Here's the trick. Let me see if I got any code over here. Let me just double check. When you first created the cursor object, that's where you should pass the things. Okay, that's exactly here. Okay, remember this is the book class, right? You can see that this is our iteration cursor. Okay, the way we initialize the iteration cursor is we pass the names and records over here. So that's where we actually give the information to the iteration cursor. However, the iteration cursor's interface does not include these two names and records. So which means any clients who wants to use the iteration cursor, they can only use after item and fourth, nothing else. All right? Again, if you see the diagram over here, the values 1, values 2, and the cursor position are completely hidden, right? Only the item after and fourth are public. Yes? You.
Okay, so in the case of lab 2, when we're implementing the iteration cursor for the 2 different options that we have, do we have to make it like implementation specific, as in like string, it has to be a string value and value, or does it just have to
Okay,
be generic?
so the question was, how would the 2 iteration cursors be different? Okay, for your lab number 2. So for example, you got one called tuple iteration cursor, and the other one is called record iteration cursor. I can tell you that the implementation for the 2 classes will be rather similar. I'll give you a little bit hints. The trick really is how you organize the generic parameters. And notice that this morning there was a forum post I answered. I think one of your colleagues, I'm not sure from which section, they asked a very important question. Maybe look at that answer as well. I would say this lab 2 over here, there's an important exercise for you to do. When you're a supplier for the database class, you're not really working with the concrete types like a string, character, or integer. Those are the types that the clients of the database will instantiate your generic parameters into. When you work for your database class, you only work with K, V1, and V2. And those are not really class names. Those are simply types, parameters that will be instantiated by the clients. Okay? So you're working with generics, right? That's more, that's rather than just assuming that always the key will be integer, or always one of the value will be string. It's too constrained, all right? Okay, guys, any question about the concept over here? Okay, yes, go ahead.
Yes, sir.
Oh.
So like the book class, right?
Yes.
What if instead of all of that,
Yeah.
one method in the book class, it returns an object, and in that object, that method, what it does is like, it goes through, for example, it takes in a parameter of an integer.
Okay, so the question is, can we simply, okay, it's a very good question. The question was, basically you want to get rid of this class over here, basically, right? You're saying that why don't I just move all the code about iteration cursor and move them just to the book class? The answer is somehow this would not be so, this solution is not so ideal since we talk about pattern, right? You want to, each class should only do one, they should be coherent in terms of their functionalities, right? So you don't really want to mix all the code into one single class. If you try to mix all the code about iteration cursor into the book class, for example, book is supposed to be just for the retrieval and storage for your records. But now you also got lots of code about how you can iterating through the stuff. So you're really mixing different concepts together. Also, that means anyone who wants to reuse the pattern over here, there's no standard to follow, right? So let's say in Java, I'm not sure about in Java, but Java is similar. If you want to implement an iterator pattern, you must inherit from certain class, maybe iterable, right? Like in Eiffel. So there's a standard for you to follow. So the across syntax will work. But if you say every developer should simply just put their code about iteration inside their application class, there's no standard over there. Also, you're mixing the concept together, right? Yeah. Okay. Any questions? Yes, I forgot about you.
I was gonna ask Professor. Oh, could we go back?
Of course. Diagram or slides?
Yeah, I was just gonna ask for the iteration cursor.
Yeah.
So you're telling us that there's 2 ways of moving the cursor position. Is it by using the after and the fourth?
Yeah. No. Okay. Remember. Okay. We'll see some example, but very briefly. Item is simply just going to return either a tuple or a record, right? Depending on how you return back to the clients. After is more like a Boolean query. It tells you whether there's any more elements to look at. It's like a has next in Java. And fourth is next elements. I want to move the cursor to the right by 1 position. So that one's a command. But we'll see some example. Okay, any more question about here? Okay, hopefully that's clearer for you, but let's see a little bit more examples and then we are done with iterator pattern. Yes.
Just like the
Yeah, so over here, the question was for values 1 and values 2. So basically, the reason that I didn't put names and records, I just want to keep them general. So here's the thing. Because this is your application class and you want to make it iterable, they used to have names and records. So the most naive solution, or straightforward solution, you simply just create the corresponding data structure over here in the iteration cursor. However, you might decide to implement slightly differently, right? So it's completely up to you how you define the internal attribute for iteration cursor. Maybe you simply just want to have a single array or single linked list. It's completely your freedom, okay? Okay, any other questions for this? Okay, so now let's see a little bit more code example. Let me see what the next one is. Okay, I want you to look at, so many of the across syntax we have seen so far, basically when you are using the across syntax, that means you are the clients of the iterator pattern. Because you say across certain thing that's iterable, you're using it. Okay, let me just show you 2 examples, okay, just for comparison. Okay, let me see after this example over here. We just got one more. Okay, we got 2 more examples to show you, and then we are done. Okay, let's say this. So so these examples are also on the slides. I just wouldn't just by reading the slides. Let's see the examples together. Let's see the first example here. I want you to look at. We have an attributes. We are using something that's iterable. Okay, iterable of integer. Versus in the second example, I'm going to use a different color here. We're using something that is a list. List is also a collection class in Eiffel, which means it's also iterable. Okay, so you can think about the hierarchy is a little bit like this. We got iterable over here as one class, which is deferred. We also got another class, which is also deferred, that's called list. Of course, under the list, somehow you also got maybe linked list, right, which is effective. Okay, that's kind of the hierarchy we're talking about. Okay, so now you can see that in the case number 1, we declare collection, something we want to cross over as iterable. In case number 2, we are declaring the attributes of type list, which is also iterable, of course. It's a descendant of iterable, so that's also iterable. So now, can you look at the code? Okay, especially I want you to look at, okay, I will look at both cases. Okay, I'll give you a few moments to look at. Can you tell me, I have a question for you. In the second case, would it work if I replace list by iterable? Let me make my question clear, absolutely clear. In the second case, if I simply replace the list by iterable, would it still work? Aha, you said exactly right to the point, okay? So the question is, as soon as we change from list into iterable, then we have to ask ourselves, is this particular feature over here, accounts is iterable, right? As we said, as we hypothetically change that into. Does that support the count feature? The answer is no. Remember, in the iterable, we only support new cursor. That's it. There's only one single feature in the iterable. So that means if, in the second case, if we simply replace replace list by something that's more general, things wouldn't compile. Agree? Okay. So now, the point is, between case number 1 and case number 2, there's really no right and wrong. I would say both are actually valid, either use list or iterable, but you gotta be careful, depending on what you need. You can see in case number 2 over here, because we want to use this kind of a construct to say from 1 into maybe the size of the collection minus 1, so that means we need the size of the iterable. But there's no size feature or count feature in the iterable. Okay? The iterable is very, very general mechanism, like here. When you say across something, collection which is iterable, you can only across item by item. That's the only thing you can do. And then you can just say cursor the item. Okay? You might be wondering, don't we have to say cursor the fourth? Or check to see if the cursor the after is true? The answer is you don't have to. If you use the across notation over here, the checking to see if it's already after or moving the cursor forth to the right position. They are done automatically for you if you use the across feature. Okay, I'll show you something quickly in the next slide. But any question about these two examples? The main thing to note is you have to be careful what you really need. If you simply just use iterable over here, that means you cannot use the count feature. For lab number 2, you might find this useful. Okay? For lab number 2, there is certain feature that returns a iterable. That means the count feature is not really available there. Okay? What you really need to do is to think in logic to see, without using the count feature, how do I specify the counter I need? Okay? That's a hint to you. Okay? If this still doesn't make sense to you, maybe revisit after you struggle a little bit more with the lab. Okay. Okay, sure. Yeah, sometimes it's hard to recall what I said. Okay. Yeah. Basically, for lab number 2, there is certain feature that returns something that's iterable. Okay. Given that we learned from the second example there, the count feature is not available for the iterable interface. So that means you cannot use the count directly in the contracts on the result. So that means you gotta think about, logically speaking, what would be the equivalent way to say without using count. Okay? That's what you gotta think about for lab number 2. Okay, can I move on to the second one? Yes, question.
So for the cursor, the type, is it return an integer?
Oh, yep. Of course, the question was, the cursor, the item over here, what's the type that's gonna return? Well, it's easy. Whatever this G is instantiated into, in this case, an integer. Of course, this will be integer, right? On the other hand, what about here? Account, right? So that means cursor item over here will be of type account. Depends on what the client instantiate the generic parameter type into.
So where do you use after and forth?
I'll show you. When to use after and forth, I'll show you. I would say it's completely up to you. Here's the principle. If you want to use the across syntax, you don't have to mention forth, you don't have to mention after. If you simply just prefer to writing the from until loop, you have to use those. I'll show you in the next slide. Okay? Let's see a final example for iterator over here. Okay? Let's see over here. You can go over the details for the logic yourself, but let's say I want to show you some important concept over here. Let's say again we got accounts over here, and then we got iterable of account. Okay? Now this is just another way to write rather than across. Okay? Which means we have to get a new cursor, and we have to call the after, we have to call the item and forth, etc. just manually by ourselves. If you just use across, everything here will be done for you. Okay? First of all, we have to declare some iteration cursor, which is called cursor over here. And the cursor is simply storing the return value for the new cursor from the account, which is iterable, right? Okay? Once we get a cursor over here, we are guaranteed the after, item, and forth features are available. Okay? We simply say, once we get a cursor, we don't have to say start. Okay? It's already started when you first initialize it. So we say until there's no more element to look at, okay? If the current item satisfies certain property, then we do something, and then at the end of the loop, we have to say cursor.forth, right? Of course, without this line here, you're gonna have infinite loop, which means your cursor never move, it never make progress. Yes?
Until stops when the boolean is false?
Until. It's like a exit condition. So it's the logical negation of what you put in the for loop. In the for loop, you say, as long as this condition is true, we stay here. Here is opposite. As soon as this condition is satisfied, we exit. Okay. Okay, now the easy question is, how do you quickly translate this whole block of code over here? How about including the local declaration here? We gotta declare the cursor. We gotta do so many stuff related to cursor. How can we write it more neatly by using across? Okay, why don't we try? This is what you can do. Okay, let me put it in green. Okay, that's basically a question over here. What's the equivalent use? So you can say across, and given that accounts is iterable, I can say across accounts. As I will try to use just the same name, cursor. So that means we're introducing a new variable called cursor. I want you to see the correspondence over here. Cursor here is just like the cursor over here. Okay? We just don't have to declare that anymore. And then I can say loop. And then end. And then I can put just this if statement over here. Okay, I'll just say if. If whatever over here, but over here you can simply say cursor dot item. Now you can see why we always have to say item, right? Say i.item or j.item in the across syntax. Okay. But notice that you don't have to say cursor.fourth. You don't have to. It's done for you. Okay. Let me just put it here explicitly. You don't have to say cursor dot fourth. That means you're going to move your cursor too fast, maybe 2 positions at each iteration. That's not right. Okay, any question about this? So left or right, which one should you choose? There's no right or wrong, depending on your preference. Okay. You will see that in the example test for the database for the lab number 2, I gave you both flavors, so you can study them a little bit. Okay, just examples for you. Okay, any questions before I move on? That's about the end of iterator pattern.
Why we don't need a cursor to
Okay, so the question was, why do we not need a cursor.fourth? The answer is because for the definition for across, right? The across basically is going to say across whatever that's iterable, you just define some cursor of the right type, just cursor. You don't have to do in this way, just have to declare the explicit type. It can be inferred by the compiler. And then over here, you just have to say cursor.item over here, just like cursor.item over here. Okay? Now, the across loop, you can think about implicitly, is going to call cursor.fourth for you at the end of each iteration. You just don't have to do it. Okay. Questions?
Oh, this one quick question, Professor. Why don't we put the precondition and the postcondition?
Oh, you know what? The question mark, that means that's for you as exercise.
Oh.
Okay, that's for you to write. Okay, but you will see that I got some hints on the slides. Please complete them. Okay. Yes.
Can you use the syntax like if conditions instead of all and some loops?
Okay, the question is, can you use the if then else like a selection syntax in contracts? The answer is yes. So go to the overview of Eiffel syntax. There's a section called selection. So you will see examples there. Okay. Yeah. You can. Yes, you can. Any questions about iterator? Okay, so let's now go on to our second design pattern, okay, which is singleton. Not again? Oh, by the way, for the resources, in case you haven't really found them, so here are the links to 2 tutorial series for just walking you through the idea about generic parameters and information hiding. If you're really stuck with how to do things for iterator pattern and generic parameter for lab 2, you can look at these 2 tutorial videos first. Okay, so they should be helpful. Well, what about I say that they're necessary? Would you watch them? Okay, good. Yes, they are necessary. They're helpful. How about that? Okay.
The lecture notes on the slides or in the iPad notes are you know.
I would say if you really understand exactly what I say in the class, you can still do lab number 2. But I would say maybe there are certain details which I didn't have time to cover in the class, but they are definitely mentioned in the tutorial video. I think they are very complete. Yeah. Also very slow. Yeah. Questions? Okay. Okay, let's go to Singleton pattern. Okay, one more thing to say. Can somebody tell me, since we have already studied the iterator pattern, so what should be the context of applying the iterator pattern? So when you see a problem there, if it satisfies certain criteria, that means, oh, I should use iterator pattern. Can somebody tell me? Huh? What do I mean by iterator pattern? So that means you gotta review the lecture up to now and last time. Iterator. What we talk about so far is the iterator pattern. Well, there are 2 aspects, right? About how the supplier supports, like 2 cases, also how the client can use for the across, right? So now the question is, when should you use the iterator pattern? Yes. When you have a collection class and then you want to do some tests on each one of them, you catch some part of it. I like it, but it's not complete yet. There's certain design principle which you haven't mentioned yet. Okay. Anyone else?
So is it traversing generic objects?
No, actually, generic parameter is just one addition to the iterator pattern. We just make it generic. Even before generic parameters is introduced, you can still do iterator pattern. It's orthogonal. Okay. Anyone else? I just need the second part. Okay.
Basically, we want to traverse to part of the class, and we don't care about the index.
Okay, you want to traverse over all the elements in your collection, but you don't care about indices. You're getting there, but not quite there yet. Okay, how about I give you some hints? How does information hiding sound in this case? So that means I have certain internal structures in my in my design, which I don't want to reveal to my clients, so I hide them. But another problem is how can I support the access to those internal structures to the clients, one item at a time? That's when you have to use the iterator pattern. So we want to satisfy information hiding, and also we want to support the access to the internal structure in a public way for the clients. That's when you want to use iterator pattern. Okay, so now let's consider a different problem context for Singleton pattern. Okay. Okay, so there are certain slides. I basically cover everything, so you can study them. Hopefully they can also help for your lab number 2 and midterm. Okay, so now let's consider 2 similar problems there. They look very different, but they're basically the same problem of the same nature. Problem number 1, let's talk about bank accounts. Let's say the bank accounts, we share certain data for each account. For example, the interest rate, exchange rate, minimum, maximum. Let's say, for example, if you want to do some international transfer for, between accounts, you definitely have to worry about exchange rates, right? If you want to do deposit, maybe you have some maximum balance limits for the accounts. And if you want to do withdrawal, maybe you have some minimum balance constraint, right? So different types of clauses that are related to bank accounts, they should have different, maybe shared data, right? That's one thing. And also one thing that's really important. Let's say I got 1,000 bank accounts, right? And then they also have some shared data. Let's say this, let's say the interest rate. Let's say interest rate might change, let's say exchange rate. Exchange rate might change on a daily basis. If today the exchange rate goes up, that new change should be published to all the existing accounts, right? To let them know the most up to date. You cannot simply just keep the old copy. That'll be inconsistent. Okay? That's one thing to note to solve the problem. And second one, if you have taken the operating system course, this will be relevant. But if you haven't, that's fine. So we're simply saying in your operating system, you got different processes running concurrently. So they are competing over some limited resources. For example, printers. You want to make sure, let's say only one process at a time can use the printer. But how do you know that currently there's at least some printer that's available? So there's some global management that's necessary, right? So that means there's some shared data that has to be regulated in a global fashion between processes. So we got these 2 problems over here, okay? So you can think about how you might solve it, but what I would do is, rather than presenting the Singleton pattern right away, let me show you one possible solution. And then let's think about how we can criticize it, okay? And then we'll see how it can lead to our Singleton pattern. Okay, so now the client, okay, not here. Okay, yes. So what I'm going to show you is one solution. This is not Singleton yet, okay? Just one particular solution. I'm going to do shared data using inheritance. The idea is simple. Put all the shared data in the superclass, parent class, and then let all the descending classes to share that same set of data. Okay, very naive solution. Let's look at that to get an idea, and then we can criticize it to see what issues we might have if we adopt this solution here. Let's say this. Already, I'll read out the comments to you. Hopefully, the comments can also be a little bit hints to you how to criticize the design. Let's say we got a deposit class which inherits the shared data, which means every deposit operation, they can get access to the shared data. However, deposit should only, let's say, deposit only care about the maximum balance. Okay? It doesn't care about interest rate, doesn't care about exchange rate. Okay? On the other hand, for withdrawal, it also inherits from the same class shared data over here, whereas withdrawal should only care about the minimum balance. Okay? So that in invariant, like a balance larger than or equal to 0 can be something like that can be satisfied. Let's say we also got another class called international transfer, in which case it also inherits from the same shared data class, but international transfer maybe only care about exchange rate at the moment, right? Or something similar. Not really everything that's in the shared data. And finally, let's say we also got an account class over here, and then also inherit from shared data. And over here, let's say interest rate might be the account should really be relevant about. If you want to do some mortgage, you have to worry about the interest rate. Also, we got some deposit withdrawals. Okay. Okay, that's about the these various classes. And then we also got the shared data over here, which you can see there's a common ancestor for all the classes over here. Let's say the shared data would put all the information here, including interest rate, exchange rate, minimum balance, maximum balance, and etc. All the information that should be shared by any of the classes related to the bank will be put here. At the runtime, for example, you might create thousands of deposit instances and thousands of account instances for each one of them, right? That's what's going to happen at the runtime. So now, my question for you, any problems you can see? You might be able to get this to work, but more talking about maintenance, okay? Yes?
I'm not sure if this is it.
Yeah.
Let's say you call an object that's deposit.
Yeah.
Can't you still call minimum balance or interest rate, exchange rate, because it's inheriting everything from shared data?
Oh, can you make your point again? I want to make sure I really understand.
Yeah, no worries. Like, let's say I create an object called withdraw.
Okay.
Can I still call maximum balance?
Of course you can. Okay. So if you create an instance of type withdraw, because withdraw inherits from shared data, that means you got all the information from the shared data, including minimum balance that's relevant, and also all the other information. Of course, you can get access to maximum balance as well.
Yeah.
Yeah.
Is that an issue?
Why would that be an issue?
Because then the client can see stuff that's not relevant to.
Ah, exactly. That's exactly one of the issues. The first issue is, I like that. The first issue is you can see basically every class over here has its own relevant information that should be accessible. However, since they inherit from the common ancestor here, which contains all the information. So that means, let's say for deposit, it also can see interest rate, minimum balance, and also exchange rate. That's kind of irrelevant. So in this way, we break the cohesion of the classes, which means you shouldn't put anything that's not relevant to the current class. Okay? That's one issue. There's another issue there.
So if you call like a dozen deposit instances,
Yeah.
aren't they all going to have different values? So you don't know which one's going to have which. Because if you deposit the first one, the second one going to have the old balance in it?
Not really. So let's say if you say deposit, right?
Yeah.
Okay. If we create thousands of deposit objects, that means each one of them is going to have their own copies of all the shared data. So there's no really issue there, right? Yeah. Yeah.
Expanding on his point, if you make like 1,000 deposit objects and you want to change what, let's say, the interest rate is in all of them, then it's going to be inconsistent
Yep.
across all the different.
Okay, that's exactly the point. Okay, so let's say this. Let's say I create, let's say for the account class, I instantiate that for 1,000 times to begin with. So that means that 1,000 account objects has separate copies of the same value, right? For all the shared data. Okay, let's say today I decide to increase the interest rate. Let's say from certain, just increase by maybe 0.1 or 0.2, right? If I do that, in this case, should I do anything to make sure the data are kept in sync? I should really go to every single object that's already been created, go there and increment the interest rate by 0.1. I got to do that. Otherwise, they will be still kept the old value because each one of them kept a separate copy of the interest rate or the shared data. No, it's not reference. Okay, let me before I take the question here, let me say something quickly. Okay. So the most critical problem for this one here is really here. Okay, let's say at the runtime, let me just make it a little bit thinner. At the runtime, I got ACC1. Let's say ACC1, and over here, that's the account, right? Remember, every account inherits from the shared data. Okay, let's say just part of the attribute, I'll say shared data over here. Okay, part of it. Also ACC2, that also is a different object over here. Okay, it's an account. Also, it's part of it is also shared data. Notice that these are basically different copies of the same value. Okay, for example, let's say currently the interest rate is 1.6, for example, right? And then we got 1,000 more object like that until account 1,000, for example. Okay, and then it also kept the same different copy of the same value currently. Okay, shared data 1.6. Okay, like that. Let's say after this, today I want to decide to change the exchange rate from 1.6 to 1.7. What should I do? I need to modify each one of them to be 1.7. I just need a loop to keep track of what objects I've created so far, and then go to each one of them and change the exchange rate accordingly, or interest rate, whatever information that should be changed. Yeah.
Fix this. Kind of make an integer object or something that's referring to the parent object of the
Yeah, I can see. So apparently in this case, you can see that the value over here is simply like a double. And double is more like a primitive type that we talk about. So it's like a separate copy, so this is not reference. But you're right, somehow this information should be shared, maybe kept in a single object, right? That's kind of the idea. Okay? That's okay. Any question about this? We're just criticizing about this design, but whatever that we criticize about is limitations that can be resolved by the Singleton pattern. Okay, so there are two limitations here. Limitation number one, okay? Actually, the diagram can illustrate. Limitation number one, you can see that every object over here for accounts is going to inherit the whole set of shared data, which include everything there. But what's relevant to each account may be just some part of it, maybe interest rate. Okay, that's limitation number one. It breaks the cohesion for each object or the class. Limitation number two, since every object there kept separate copies of the shared data value, if you want to do constant updates on the shared data, maybe exchange rate from 1.6 to 1.7, in that case, you have to go to every object of the right type that has been created so far, and then change the value accordingly. Okay, that's limitation number two.
Yeah, my question was, is there any way of declaring static variables?
Okay, that's something thinking about static is a good direction there. But what I will show you is, while we're going to present a Singleton pattern here, it's not exactly like static in Java. I will show you what the limitation is for Java static. I will show you that. Okay. Again, we're talking about design, right? For implementation, you might just be able to use static somehow. Okay. Okay, let's now go to the next one. Okay, that's about the criticism, but you know what? These two limitations are also summarized here more briefly, but you can also look at them. Okay, number one, breaking the cohesion for the descending classes. Number two, you have to make sure the data are consistent. Okay, so these are the two limitations. Okay, so I can read them through. So here is the solution. Apparently, there are two different concepts over here. We have the shared data. And we don't want to keep so many copies of the shared data. We want to keep just a single copy, right? So we got a shared data itself and also some shared access to the data. So these are the two concepts we want to maintain. Okay, first of all, let's get it straight. So it used to be the case that it's only a shared data, a single class. But somehow we want to split that into two classes over here. So one class is just going to maintain the shared data. The other class is going to be managing these access to that particular data. Okay? That's kind of the idea, high level. Okay, but how do we do that? I'm going to show you in just a moment. Okay, so we're going to encapsulate the shared access in the separate class. Okay, but how do we do that? So there's one single keyword you have to learn in Eiffel. Okay, but I'm going to illustrate to you how it works. Okay, by using the example. Okay. What I will do is I will show you the code on the iPad, and let's go through it together. So let's have a look at this one here first. Okay, let's have a look at this one. Let's, as a warm-up, nothing new just yet, but let's have a quick look. Let's say I have a feature called new array. Okay, and then it is going to basically just return. Okay, let me show you some code here. I think it is something I kind of ignored from this iPad here. Okay, can we just have a quick look? So let's say over here we have a class. Let's say we have a class A, and then under the class A, we have two queries over here. We have two commands, basically. And then we are trying to, okay, so we are trying to create a returning array in both cases. So in one case, it's called new once array. The other one is called new array. One of them is using the keyword called do, okay, which we are used to up to now. And the other one is just going to call the once keyword, which is new to us. Right, we're going to explain the difference between them. Okay, it's just a quick overview. And now we're going to see exactly how we can do it. Okay, let's see. Now, let's go back to iPad over here, and let's do the one that we are familiar with already. There's no attributes in the class, so let's just focus on the feature. It's returning something, very simple. So now let's say, for example, over here, let's go over that. When I say create a.make, it's going to make an empty array. That's a test. And then I'm going to say a.newArray Alan. That means I'm passing Alan as S over here. So that's going to be Alan. So what does it do? It simply say, it's a normal do here, over here. It's going to create just an array, initially to be empty, the returning array over here. And then it simply put the string into the array. That's it. Very easy. So after this, what we can expect is ARR1 is going to point to a new array over here with just one element. And then index 1, let's say, and then it's going to point to a string, just Alan. As easy as that. Okay, that's what this will do. So that's why we check to see AR1.count will be 1, and also the first element should be Alan. Okay, so far so good. Let's do the second one. The second one over here, let's say we try to call a.newArray the second time on the same object A. Okay? And then we pass a different value in this time, mark. So let me use a slightly different color here. How about mark over here? So that means this time we're going to pass mark. Okay, if we follow exactly the same block of code, we're going to create just a new array being empty, and then we're going to put inside the array just this new mark over here. So what do we expect to see after this line here? Well, we're going to see ARR2 is going to point to just a new array, right? And then it is going to point to mark. That's why we do the check again. Count will be 1, and also the element will be just mark. Okay, nothing surprising here. And then we can be sure these two arrays are not of the same reference. AR1, AR2, they are not the same reference. So far so good? Okay. The reason I'm doing this just because the new keyword I'm going to introduce will give you some very unique behavior you have to be aware of. That's why. Okay. Now, let's now switch to something basically almost the same for the feature over there. Rather than having the do keyword, I'm going to have once. Okay? Let's see what's going to happen here. Over here, you can see the difference is I have once over here. But these two lines are exactly the same as before. Just the same. Just create empty array, insert element into the array. Okay? Let me just tell you informally what once would do. once literally simply means we're only going to execute the body of this feature once and for all. Only once. But your question might be, what about if I try to call this new once array the second time? It is not going to execute this block of code anymore. Whatever you return for the very first time, return the same reference. If you execute for the third time, return the same reference, and etc. Let's keep this in mind informally. Let's see exactly how this is going to work. And then we'll try to see why this new keyword can help us implement the singleton pattern. Okay? Let's see that first. Let's see this. Let's go over the code. First of all, we have a object over here, so we can call a new once array. And then let's say ARR1 is assigned to a dot new once array. I want to highlight this line over here simply because this is the very first time that we are trying to call this particular feature. Okay, I'm going to put that for you. The first time calling this once feature. Sorry, spelled it wrong. The very first time. When we call that the very first time, we'll do just what we did before. Okay? What we will do is we'll simply create an array internally, initially empty, and then force the element into it. Okay? So what we will get is something like this. You can think about, let me just put it like this. Whatever that's returned from this very first time of execution here, let's say I'll just say first array. How about this first result? The first result from there is going to be an array of size just 1 as before. It's going to point to just Alan. Same as before. And then of course ARR1 is also going to point to there. Okay, you can think about this is the return value from the new once array over here. Okay, that's the return value. And then ARR1 is simply assigned to it. Okay, so far so good. Now, it shouldn't be too surprising to you. The first element there should be Alan, right? So far so good? Or you got questions? Yes. I just say first result. So the name over here, I simply, Eiffel is going to manage this, so you don't have to worry. The idea is the result, the return value from the new once array is going to be stored somewhere, okay, for the very first time after executing the body of the code. And then any subsequent calls to the same once feature is going to just return this value. You don't have to execute the body anymore. Okay, let's see exactly what's going to happen. Okay, so now let's see, I want to highlight this line over here in a different color here. When I say new once array over here, I use a different color. Okay, this is already not the very first time. Not the first time. Return the cached value. On the other hand, when we call that for the first time, execute the implementation. Okay? So, if you try to call that the third time, fourth time, or fifth time, doesn't matter. As long as it's not the first time, just return the cache result. Okay? So now, what would be ARR2 then? First of all, do you think mark is going to make any difference over here? No. Even though we're going to pass mark over here, but it's irrelevant in this case because this body has been executed for already once, only once. It's not going to affect anything. That means ARR2 is simply just going to point to the same object over here. So that means you will see still Alan here. It doesn't matter what you put over there as Mark, Tom, whoever, doesn't matter. You just ignore it. You only return the very first calculated result for all the subsequent calls. Correct. That's it. So basically, okay, let me summarize again. So whenever you declare once as opposed to do, that means the body of the feature usually query is only going to be executed only once for the very first time. For any subsequent calls to the same feature, you're just going to return the same value. Okay, that's being calculated the first time. Okay, one more thing to show. Okay, let me just say this. Okay, and then you can see that if we try to compare the references for ARR1 and ARR2, right, they are the same, as opposed to being different, right, in the previous case. Okay, question.
So you can never override what's if you want to change the
In this case, no. Once you actually execute for the very first time, you cannot change it. Okay, so now based on this diagram over here, can you see any connection to how we implement something that can be shared? We'll get there. We'll get there. You can still change it. You can still change it. Yes. Okay. Yeah. Questions? What do you mean stays there? Yeah. Whatever result it is from the first time execution is going to stay there. It's not going to be executed anymore. Just stay there as a result. Yes.
Yeah, Professor, for this one, we're basically doing aliasing, like.
You can think about it as more like aliasing. Yes. We just return the same result because the return value here is a reference type, just array. So you always return the same array.
Okay, so basically, if you modify some value within AR2, it also changes to AR1.
Correct.
Okay.
Correct. That's absolutely correct. So now, one more thing to say. So now, since we know ARR1, let me just mention your point. That's a very good point. Because ARR1 and ARR2, they're pointing to the same objects. If I say ARR1 at position 0 is assigned to, for example, Mark, what would be ARR2 at position 0? Will be Mark, right? Because if I change that, because they're aliased, so that'll be Mark. Okay, just to emphasize. Now, how is this going to be connected to our singleton pattern? So now, thinking this way, once would be very useful for creating access to some shared data. You can think about what we talk about as array over here, like this object over here. This can be some shared data. And every time when we try to, only for the first time, we're going to initialize the array, right? For the very first call. For any consequent call, subsequent call, we just return the reference to the same shared data. Just the same. Okay? So, and just let me say one more thing before, yeah. And then it doesn't matter which clients we use to actually change the shared data. Once it is changed, it can be visible to everybody. Okay, that's aliasing. Questions before I? Yeah, that's how we update. You can just go, so you can think about ARR1 is some client reference. They also got access to the shared data. It's just that when you return the access to the ARR1, ARR2, they refer to the same objects.
So this goes back to like changing back interest rate.
Okay, exactly. We'll see that in just a moment. Yeah. So we're gonna see how this can be applied to the bank account. I'll show you in just a moment. Question? Yeah.
If you call new one to array with, or on array one, and then let's say you use the reference to array one instead of the void, if you called it again, you then make another new call.
Oh, okay. Let me see if I understand you correctly. It's kind of interesting question. The question seems to be the following. Can we just say hypothetically, okay, just say starting from here, okay, I'm going to put it here, okay. You're saying that I might say ARR1, first of all, is assigned to A dot new ones array, and let's say it's still Alan. And then you're saying that I'm just going to assign that to something, right? Let's say temporarily. Let's say ARR1 is assigned to void. Sorry? So that means we lose the reference over here. Now the question is, if we try to do ARR2 is assigned to A the new ones array, and then put something over here. Okay, that's your question, right? Okay, the question is, it's going to be the same behavior. It only matters like which time you're trying to call that. This is the very first time. That means Alan has been fixed over there, has been fixed. And this is already the second time that you're trying to call that. Doesn't matter if you lose the previous reference or not. If you lose it, too bad, right? But now over here, since you're calling that for the very not the very first time, it's going to be just the same reference to the array, okay? Yeah. So somehow the runtime management system for Eiffel is gonna do this for you. Okay, question?
Are calls of new once array consistent between different instances of the object?
So how is the new once array over here consistent? Okay, the answer is, okay, let me repeat the question. The question is, in this case, how can the value for this array over here being consistent among ARR1, ARR2, and all the client references, right? Okay, the answer is aliasing. Because you can see ARR1 is pointing to here, the same array. ARR2 is also pointing to the same array. So now it doesn't really matter whether you use ARR1 to change it or use ARR2 to change it, because you're modifying the same objects. So once you make any change into here, it's going to be visible to all the references. Oh, I see. You're saying like a A1, maybe have A1 and A2, right? It doesn't matter. Again, still, the very first time. Doesn't matter you use A1 to call the new once array or A2 to call the new once array. As long as it's the very first time, you will execute the body of the feature. Once after that, it will just be the same. Okay. Guys, any more questions about this? Okay, what I would suggest before next Tuesday's lecture, review this code example quickly, and then we'll finish the Singleton pattern, and then we'll go into inheritance. Okay, one more thing to mention, okay, just before you leave. For next Wednesday, I cannot really go to your lab sessions, so I'm going to announce some additional office hour on Monday and Tuesday instead to help you with your lab number 2 if you need it. All right? Okay, see you.